Here's an example of a word problem. The first thing that I would do when I see this word problem, especially the one that has a big paragraph, is to not read through this and be scared, but to skim through it and find out what I'm looking for. So I want to find what my goal is. I want to know what my goal is. So usually it's located at the end of the paragraph. Just gonna skim through this, and I notice I'm looking for how long will it take the B737-800 to overtake Saab 340B. So let's jot that down. My goal here is to find how long it will take for B737-800 to overtake the Saab 340B. And how long means I'm looking for time. So time equals, and skimming through this paragraph, I see a lot of MPH, hours. So the units for time here would be hour. Now that I know what my goal is, I know what I'm looking for, I'll go back and read this paragraph and jot down relevant information. So here we have Delta Airlines fleet includes B737-800, each with a cruising speed of 517 miles per hour. So let's jot that down. We have the B737-800's speed is 517 miles per hour. Then we have the Saab 340Bs, each with a cruising speed of 290 miles per hour. So we have the Saab 340Bs, speed 290 miles per hour. It says, suppose a Saab 340B takes off and travels at its cruising speed. So here we have Saab takes off at a cruising speed. So cruising speed is the same as the rate. So I'm just gonna say rate equals, and we know the cruising speed is 290 miles per hour. 1 hour later, a B737-800 takes off and follows the same route. So here we have an hour later. We have the B737-800 takes off at cruising speed, and the cruising speed we jot down earlier was 517 miles per hour. And again, our goal here is to find how long it would take for B737-800 to overtake Saab. So looking at this problem, I notice speed, I notice I'm looking for time, and when B737 overtakes Saab, that means that's when the distance is equal, that's when the distance is the same. So overtakes, that's when distance B737-800 distance is the same as the distance for Saab 340Bs. So again, this problem involves rate, distance, and time. The equation to represent distance is equals to rate times time. So let's put that in the equation. The rate for B737 is 517, and the time would be t. So that's what we're looking for, time. For B737, that would be t. Now for Saab, we cannot use t for Saab because the time for Saab and the time for B737, they're different. We know that because B737 takes off 1 hour later, that means SAB has been traveling for an extra hour. So the time for SAB is going to be T plus 1. This one travels for a longer period of time. So for SAB, the distance, again, rate times time. Rate is 290, and the time is T plus 1. So here we have a linear equation with a variable T, which we can solve for. Distribute the 290T plus 290 equals 517T. Then we subtract 290T from both sides. And we end up with 7 and 227T equals 290. Then we divide 227 from both sides, and we would end up with T being about 1.28. So the time it takes for B737 to overtake SAB is about 1.28 hours. B737 800 will overtake SAB 340B in about 1.28 hours after it had taken off.